All of you welcome in our next period of mathematics paper 1, differential and integral calculus. We see the next mean value theorem, which is the Cauchy's mean value theorem. The statement of the Cauchy's mean value theorem is f, and g are continuous functions on the closed interval AB and are differentiable on open interval AB. Then there is a point C, right here. Then there is a point C belongs to open interval AB such that f of b minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c, where the condition is g of a is not equal to g of b and f dash and g dash are not simultaneously 0. We see the proof of the theorem. We define the function h of x and h of x equal to this f of b minus f of a into g of x minus g of b minus g of a into f of x. Here f of a, f of b are constant, g of a, g of b constant, and these are the g of x, f of x are differentiable function which are the functions of x. Now it is we define this h of x for every x belonging to closed interval AB. Now since we are given that in the theorem f of x and g of x are continuous, therefore h of x defined by this g of x, h of x and constant, the right hand side is continuous, therefore we say that the function h of x is also continuous. And also it is differentiable, h of x is differentiable on the open interval AB. Now in the equation 1, we put x equal to a, we get h of a, we put x equal to b, we get h of b. For x equal to a, we have f of b minus f of a into g of a minus g of b minus g of a into f of a. Now solve this, simplify, you will get f of b into g of a minus f of b into f of a. You solve this, one term gets cancelled. Now similarly we put here x equal to b, therefore h of b equal to f of b minus f of a into g of b minus g of b minus g of a into f of b. Again simplify this, you will get the answer as f of b into g of a minus g of b into f of a. Now from equation 2 and 3 you will observe that h of a and h of b are same. F of b, g of a minus g of b minus f of a. Here also we get the same value. Therefore from equation 1 and 2 we say that h of a equal to h of b. Hence all the three conditions of the Rolle's theorem are satisfied. You know the Rolle's theorem, there are three conditions. F of x is continuous on the closed interval AB, it is differentiable on the open interval AB, and f of b equal to f of a, then we have f dash of c equal to 0. Therefore there exists a point C belongs to open interval AB such that f dash of c equal to 0. Now here f dash of c, we have to find first derivative of this h of x. Therefore differentiating equation 1 with respect to x. Therefore derivative of h of x, h dash of x equal to, this bracket is constant, f of b minus f of a is constant, therefore derivative of g of x, g dash of x. Similarly this second bracket is constant, g of b minus g of a is constant, derivative of f of x, f dash of x. Put here x equal to c. Now we have to take this h dash of c equal to 0, therefore we have to put here x equal to c, so that we write here f dash of c equal to 0. Therefore we have, now put here x equal to c, therefore we get here g dash of c, here we get f dash of c. Therefore the first bracket into g dash of c minus the second bracket into f dash of c equal to 0. Now take one side in the other side, one term in the other side, therefore we have g of b minus g of a into f dash of c. We take this second term on the right hand side, therefore we get this g of b into g of a minus into f dash of c equal to the left hand side f of b minus f of a into g dash of c. Now dividing the equation by cross multiplying, by cross dividing g dash of c, here we will divide Here this bracket gets divided here on the right hand side. Therefore, your f dash of c divided by g dash of c equal to f of d minus f of a divided by g of d minus g of a. Or we can write this term equal to this left hand side. Therefore, f of d minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c, where this c belongs to the open interval AB, and hence the Cauchy's mean value theorem is proved, because we have to prove there exists a point C belongs to AB such that f of b minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c, provided that g of a is not equal to g of b and f dash of g dash are not simultaneously 0. Then the theorem is proved. Now if we take here g of x, if we take here in this theorem g of x equal to x, then this theorem, Cauchy's mean value theorem, reduces to the previous one theorem, that is Lagrange's mean value theorem. That is, if g of x equal to x, then Cauchy mean value theorem implies the Lagrange's mean value theorem. Then we see the examples on this theorem. Verify the Cauchy's mean value theorem for the functions. The first function f of x equal to x square and g of x equal to x cube in the interval 1, 3. Second, f of x equal to e to the power x g of x equal to e to the power minus x in the interval, closed interval AB. Third example, f of x equal to 2x square plus 3x plus 1 and g of x equal to x square minus 3x plus 2 in the interval 0, 3. Let's see the first example solution. here f of x equal to x square and g of x equal to x cube are continuous on 1 3 and these are differentiable on the open interval 1 3 because these are the polynomial functions. Since these are polynomials, now in the Cauchy's mean value theorem, we have this f dash of c, g dash of c, and the condition is g of a is not equal to g of b. Therefore, we find g of b, g of a equal to means g of 1, a equal to 1 and b equal to 3. G of 1 cube equal to 1 and g of b, that is g of 3 equal to 3 cube, that is 27. Therefore, observe that g of 1 and g of 3 are not equal. Here we get 1, here we get 27. Implies g of a is not equal to g of b. Therefore, all the three conditions of the Cauchy's mean value theorem are satisfied. Hence, all the three conditions of the Cauchy's mean value theorem are satisfied. Therefore, according to Cauchy's mean value theorem, there is a point C belongs to open interval such that, write the statement. Implies there exists a point C belongs to open interval AB such that f of b minus f of a divided by g of b minus g of a equal to f dash of c divided by g dash of c. We put values. F of b means b equal to 3, f of 3, therefore 3 square minus f of a equal to 1, therefore 1 square divided by g of b, means x equal to b equal to 3, therefore 3 cube minus g of a means x equal to 1 here, 1 cube equal to f dash of c. First find the derivative of f of x. F dash of x equal to we get 2 twice x and g dash of x we get 3x square. Therefore, I put x equal to c. Therefore, twice c divided by 3c square. 1 c get cancelled, we have 1 by c. Therefore, we get 9 minus 1 divided by 27 minus 1. Here 1 c cancel, therefore 2 divided by 3c. Therefore, 8 divided by 26 equal to 2 by 3c. Therefore, by cross multiply, 3c equal to 2 into 26 divided by 8. Therefore, we will get 2 4 by 8, 26 by 4. Therefore, we obtain c equal to 24 divided by 26 by 4 into 3. Again, here we have 13 and we have 6. Therefore, 13 by 6, which is equal to, solve this, 6 to the 2 point. The value we get 2.1. Like this. Now observe that this value of C lies in the open interval 1 3, which is this value is greater than 2 and less than 3. Therefore, it lies in the open interval 1 3. Therefore, C equal to 13 by 6, which belongs to open interval 1 3. Hence, Cauchy's mean value theorem is verified. Verified for the given function. Given functions x equal to f of x equal to x square and g of x equal to x cube. We'll stop here.